Exploring the Universe by Jane Green. Where in the universe is Earth? Space. People studied the sky and the objects in it as far back as 3500 BC. In 1609, the Italian scientist Galileo Galilei became the first scientist to observe the stars through a telescope. It allowed people to see even farther into space than they could with just their eyes. His theories and findings about the universe changed astronomy forever. Scientists have developed many other technologies to help answer questions we have about the universe. Recent technological advances, such as more powerful telescopes and probes launched into space, have further contributed to what we know about our solar system and our galaxy, the Milky Way. A galaxy is a huge grouping of stars. Galaxies are found throughout the universe and can have different shapes. The Milky Way galaxy is shaped like a pinwheel and is known as a spiral galaxy. Some galaxies are elliptical or oval-shaped. Irregular galaxies have no particular shape. The Sun is in one of the arms of the spiral and is only one of at least 100 billion stars in the Milky Way. The galaxy spins within the universe and makes one complete rotation once every 200 million years. The Solar System. Our solar system is made up of the Sun and 9 planets, including Earth. These 9 planets orbit the Sun. The Sun's gravity keeps the planets in their orbits. The orbits of all of the planets except Pluto are almost circular. Natural bodies called moons orbit most planets in the solar system. Some planets have only one moon, while others have many. Mercury and Venus do not have any moons. Other objects also orbit the Sun in our solar system. More than 100,000 asteroids orbit the Sun. Asteroids are small bodies made of rock and metals. Comets orbit the Sun in long, narrow, oval paths. Comets are made of ice. When a comet goes past the Sun, some of the ice turns into gas, forming the tail of the comet. One of the most famous comets is Halley's Comet. It passes close to Earth once every 76 years. Great distances separate the objects in our solar system. Scientists use a measurement known as an astronomical unit, or AU, to measure these distances. An AU is about 149.6 million kilometers. It is about the same as the average distance between Earth and the Sun. Scientists classify the planets into 2 different groups. Mercury, Venus, Earth, and Mars are called inner planets. They are closer to the Sun and have solid rocky surfaces that resemble the surface of Earth. Jupiter, Saturn, Uranus, Neptune, and Pluto are outer planets. They are farther away from the Sun. With the exception of Pluto, the outer planets are mainly composed of gases and are extremely large. Pluto, the planet that is farthest from the Sun, is different from the other outer planets. Pluto is small, solid, and more like the inner planets. The planets of the solar system. Mercury. This planet is rocky with craters formed by meteorites. There are traces of hydrogen and helium in the atmosphere. Venus. Very hot and mostly rock with craters. Venus may have some active volcanoes. Its atmosphere is mostly carbon dioxide with clouds of sulfuric acid. Earth. Mostly water-covered. Earth is the only planet known to support life. Mars. This planet has craters in its southern part and white polar ice caps. The atmosphere contains mostly carbon dioxide. Strong winds blow red surface dust, which makes the sky pink. Jupiter. Jupiter is covered by liquid hydrogen and is very cold. Its atmosphere is mostly hydrogen with clouds of ammonia crystals. Saturn. Ice and liquid hydrogen surround a core of rock and metal. Saturn is very cold. In the atmosphere there are strong winds and swirling clouds of ammonia. Uranus. The atmosphere is made up of mostly hydrogen and helium. Uranus appears blue-green in color. It is the only planet that rotates on its side. This makes it appear to roll through space. Neptune. This planet is possibly covered by liquid hydrogen and helium. The atmosphere is mostly hydrogen and helium. Neptune appears pale blue in color. Pluto. This tiny planet is made mostly of frozen methane, ice, and small amounts of methane gas. There is an ice cap at its north pole. The orbits of all the planets are roughly level, except for Pluto's, which tilts at a different angle. Pluto's orbit is also more elliptical. The orbits of the other planets are almost circular. All the planets orbit the Sun in the same direction. How planets are arranged. The distances between the planets in our solar system are so great that it would be difficult to show a scale model in this book. In the previous 2 pages, you saw the arrangement of the planets, but not the actual distance between them. The chart below shows what the relative distances between the planets in our solar system would be if Earth were 1 millimeter wide at the equator. The sizes of the planets relative to Earth are also listed. If you looked at a ruler, you would see that 1 millimeter is very small. Now look at how far Earth is from the Sun using these scale sizes, 11.7 meters. If Earth were the size of a marble, the Sun would be about 100 meters away. That is longer than a football field. Planets are unique. The distance between a planet and the Sun can affect the temperature of a planet. For example, Venus is twice as close to the Sun as Mars, so it is much warmer. But distance is not the only thing that determines its characteristics. Based on distance from the Sun, you might expect Venus to be a little warmer than Earth, but not as warm as Mercury. This is not exactly true. Temperatures on Mercury range from about 467 degrees Celsius during the day to minus 183 degrees Celsius at night. Average temperatures on Earth range from 36 degrees Celsius to minus 13 degrees Celsius. The average temperature on Venus is 453 degrees Celsius. It does not change through seasons or from day to night. These differences occur because a planet's atmosphere also affects its temperatures. Although Venus and Earth are about the same size and their orbits around the Sun are close to each other, Venus is surrounded by an atmosphere of carbon dioxide and clouds of sulfuric acid. This sort of atmosphere traps heat. Mercury has a very thin atmosphere that does not protect it from the Sun's powerful rays. Because of this, days on Mercury are very hot. But the atmosphere is too thin to trap heat as well, which is why Mercury's nights are so cold. Stars shining far away. Stars. A star is a huge ball of hot glowing gas. The intense heat and pressure at the center of a star cause the atoms there to crash into each other at extremely high speeds. The nuclei of 2 or more atoms may join during this process to form a larger nucleus. This process is called nuclear fusion, and it gives off huge amounts of energy. Some of the energy produces radiation and light energy, which allows us to see stars that are very far away. Star distances. We use astronomical units to measure distances within our solar system. Distances in the vast universe are even greater. An AU is too small, so light years are used instead. A light year is the distance that light travels in 1 year in a vacuum. It is equivalent to 9.46 trillion kilometers. The light from the Sun, the closest star to Earth, takes about 8 minutes to reach Earth. The next closest star to our galaxy is Proxima Centauri. The light from Proxima Centauri takes about 4 years to reach Earth. The light from most of the other stars we see can take millions or billions of years to reach Earth. An eruption of very hot gas on the surface of our star, the Sun, is called a solar flare. Brightly glowing stars. Astronomers use the term magnitude to describe the brightness of a star. The term apparent magnitude is used to describe the brightness of a star as we view it from Earth. The Sun is the star with the greatest apparent magnitude. It appears the brightest to us. Absolute magnitude is another way astronomers measure star brightness. It is the measure of how bright stars would appear if they were all the same distance from Earth. Some stars that look tiny and dim from Earth are actually more than 150,000 times brighter than the Sun. Their absolute magnitude is much greater than their apparent magnitude. The color of stars. Some stars appear to be different colors. If you look through a telescope at night, you may be able to see red, yellow, white, or blue stars. The surface temperature of a star determines its color. Red stars have temperatures between 2,000 degrees Celsius and 5,200 degrees Celsius. These are the coolest stars. Yellow stars, such as our Sun, have temperatures that range from 5,300 degrees Celsius to 7,000 degrees Celsius. White stars are even hotter, with surface temperatures of 7,200 degrees Celsius to 9,500 degrees Celsius. The hottest stars burn blue. Their surface temperatures can range from 10,000 degrees Celsius to 50,000 degrees Celsius. Mid-size stars. Stars such as our Sun glow yellow for about 10 billion years. Red giant. This huge reddish star has a low surface temperature because it has used most of its hydrogen. Red giant stars are larger than the Sun. Life cycle of stars. Stars shine for billions of years, but they eventually stop shining. They change throughout their lives in many ways. A star forms inside a nebula, which is a cloud of hydrogen and other gases. Gravity holds the gas particles together and pulls in more gas particles. Nuclear fusion begins when the inside of the star reaches about 10 million degrees Celsius. Fusion produces hot gases that push away from the center of the nebula. Gravity pulls these gases back. When the push of these gases becomes stronger than gravity's inward pull, a new star is formed. Nova. Some stars have a partner star. If one star in a pair is a white dwarf, its gravity can attract gases from its partner. The dwarf may explode if it collects enough gases. On Earth it would look similar to a new star. Such an explosion is called a nova, which means new. White dwarf. A white dwarf is what is left when a red giant slowly loses its outer gaseous layers. Black dwarf. These dead stars have used all their fuel, so they do not shine. Massive stars. A massive star glows blue for about 1 to 20 million years. It is 10 to 30 times larger than the Sun. Supergiant. This extremely bright star is a huge type of red giant. Some can be 10,000 times brighter than our Sun. Antares A is a supergiant star about 700 times the size of our Sun. Supernova. A supergiant that goes through a violent collapse explodes as a supernova. It is far brighter than an ordinary nova. It can be 10 billion times as bright as the Sun. When this happens, it becomes a neutron star, or even a black hole. Constellations. Constellations are groupings of stars in the night sky. Constellations were first identified by ancient civilizations. The Babylonians identified the 12 star constellations that make up the zodiac around 450 BC. The ancient Greeks identified and named 48 constellations. They named these constellations after mythological people, events, animals, or objects. The constellation Orion was named after a hunter who fell in love with the goddess Artemis. According to the myth, after Artemis accidentally killed Orion, she put him in the sky. The Big Dipper is one of the most well-known constellations. It is part of the Ursa Major constellation, which means Big Bear. The North Star is found in a straight line from the end of the bowl of the Big Dipper, and has been used as a point of reference by navigators for centuries. Movement of constellations. As Earth rotates on its axis, the nighttime sky appears to change. The positions of the stars look different in the early evening than they do just before the sun rises. The positions of the stars in the night sky change also because of Earth's movement around the sun. The night sky changes during the year, just as seasons change. As Earth revolves around the sun, the constellations that you see appear in different places in the sky throughout the year.